Sir, you are not audible.
Let us fix this problem and I'll go for the pattern of the examination. Next, the bending moment diagram. The, the bending moment diagram will be, say again, we are taking this section at a distance x from the left end. So here only one force is acting, that is the reaction Ra, which is 4 kilonewton by the amount, and it's away by distance x from the section, and it is creating a counterclockwise moment. So it will become positive. The moment is positive here, that is mx is equal to 4x. And at the point when x is equal to 0 means at the point A, then ma is equal to 0 and x is equal to 2 when at the point C, then mc is the 8 kilonewton per meter. Next, the portion CV here, from here to here, if it is at a distance x from left end, this section, there are two forces acting, that is the Ra, which is equal to 4 kilonewton, and a point load W, 12 kilonewton acting downwards, and they couple at 24 kilonewton meter per meter, 12 kilonewton meter at the point C. So if we take the moment, clockwise moment as positive, so Ra into x will be 4x is positive, 24 kilonewton is a clockwise moment as per a given problem, that is positive, and 12 kilonewton multiplied by x minus this two distance, x is from here to here and 2 is from here to here, 2 meter is from here to here. So from here to the section, from the point C to the section, distance will be x minus 2. So 12 multiplied by the x minus 2, as it is creating an anti-clockwise moment, so it is creating, it is become negative. So that is, let's say at the point C, means where x is equal to 2, then MC will be 32 kilonewton per meter, and at the point 6, where x is equal to 6, then MB will be 0 kilonewton. So kilonewton meter. So the bending moment will be starting from 0 to 8 kilonewton, then it becomes 82 to 32 kilonewton at C, then it reduces to 0 kilonewton at C, at the point at the end T. Now, let us go for the shear itself. Whiteboard. Mhm. Examination date is given in the notice. চালাতেও পারে। Exhibition time चलिए खेल रहे वाह So now the question here will be given like this. Total time will be 55 given. The examination details is given in the notice. Also, a notice also given about the total timing of the exam. And you have to do that, to make all the questions, all the answers on a piece of paper or a multiple piece of paper. And first 5 questions will be the objective type. You have to write down the answer of your piece of paper, and then on the same paper you have to answer the answer of the descriptive question. There will be 3 descriptive questions of 5 numbers each, and 1 question, 1 number each. That is total 20. Now, this will cover shear force and bending moment diagram, simple stress and strain, and multiple stress analytical and strength mode cycle process. Okay, and how to upload your question and where you have to upload your question, it will be given in short by this week. Maybe Google Classroom or maybe some other form. ठीक है. Let us go through the next share. Now, let us go to the problem number 20. Here, a 10-meter long, simply supported beam carries a point load of 4 kilonewton at 8 meter from the left end with uniformly distributed load 4 kilonewton intensity for 3 meter length starting from left end. Beam also acted upon by clockwise couple of 10 kilonewton at the midpoint of the spin. Draw the shear force and bending moment diagram. Here, it is not otherwise mentioned, so you're thinking that supports are given at the end A and at the end B. So here, what is given? We have a distributed load from A to C, that is 3 meter in length and with intensity 4 kilonewton per meter. We have a couple at the point T with 10 kilonewton but acting clockwise direction. We have a point load 4 kilonewton at the point E, which is acting downwards. So first of all, again, we have to calculate RA and RB. RA, we have to take moment about the B. So RA multiplied by the distance 3 plus 5 2 5 5 plus 3 8 plus 2 10. So RA multiplied by 10 meter with the distance which is equal to which is clockwise in nature, and other forces, that is the distributed moment of the distributed forces will be 4 multiplied by total length 4 into 3 multiplied by 8.3, 8.5. 8.5 means it is center line of action. It will be supposed to be on the center, which is away by 1.5 meter from left end. So it is away by 10.5 from the right end. Next, 10 kilonewton minus 10 kilonewton, which is acting clockwise direction. So it is supposed to be negative to maintain the balance, and plus 4 into 2, that is 4 multiplied by anti-clockwise direction, so it is positive, that is 4 into the distance 2. So thus after simplification and calculation, we know RE will be 10 kilonewton. And we take the vertical direction loads of the vertical direction, then RA plus RB will be equal to 4 into 3 means 4 multiplied 4 the intensity load multiplied by the distance 3 plus divided by the 4 which is acting downwards, and plus 4 kilonewton which is also acting downwards, and thus RP will be 4 into 3 plus 4 minus 10, where 10 is the RA the reaction at A concern. So that will be 12 plus 4 16 minus 10, that is equal to 6 kilonewton. So RA will be 10 kilonewton, RB will be 6 kilonewton. Let us go through the shear force diagram. If we take the section here, it is now the portion A to C. Let a greater consider section at a distance x from the end A. So there we will have a vertical force from A to X section. We will have a vertical force acting upwards, that is 10 kilonewton, and downward force 4 multiplied by X, 4 multiplied by X acting downwards. So the Fx 10 Fx equal to 10, which is positive because it is acting upwards, and equal to minus 4x, which is negative, that is acting downwards as per our sign convention. So if A is equal to 10 kilonewton, and when x is equal to 0 at the point A, and if A is equal to f C, which is where x is equal to 3, is equal to minus 2 kilonewton. So x is changing from 10 to 2 kilonewton, minus 2 kilonewton. Thus, the shear force from this portion will be at the end A, it will be 10 kilonewton, and at the end C, it will be 2 kilonewton, and somewhere in between, it will become 0. The problem, the distance CE, where we are having vertical forces like RA, as well as vertical forces that is 4 kilonewton per meter. And if we take the section up from here to here, so not here itself, because there is no change in the force. So this is the X here. So there is one vertical force 4 kilonewton per meter acting downwards, another vertical force 10 kilonewton which is acting RA, that is acting upwards. So we know that shear force will be positive if it's acting upwards, and it will be negative when it is acting downwards. So the shear force here to 10 minus 4 into 3, that is equal to minus 6. And the portion EB this here we have from which if we take section X here, which is away by the point A, from the point by X. So what will happen? We have vertical forces A are a distributed forces 4 into 3 and vertical forces 4 into K acting downwards. Thus, shear force RA will be portion EB, or you can, this is taken the portion from the right end. So 4 kilonewton, RP is 4 kilonewton here, 6 kilonewton, and there is no other force, and it is acting upwards. So it is at its right, it is right side of the section, it is to be negative. So shear force at the section at between E to B is going to be minus 6 kilonewton. The shear force diagram will be 10 to 10, and it becomes 2.2 kilonewton. Then it becomes at the point E, it is 2 kilonewton minus. Then it will become at the 6 kilonewton minus at up to the point P. Now, what is the bending moment diagram? The portion AC from here to here. Here only one force RA, which is making a clockwise movement about the section X, and 4 into X is the distributed load acting at a distance X by 2 in between at a distance X by 2 somewhere here. So it becomes 410 into X multiplied by 4 into X multiplied by X by 2. So 4x squared by 2, or 10x squared minus 2x squared, which is also parabolic in nature. At x a is equal to 0, when at x is equal to 0, a is equal to 0, and x is equal to 3, MC will be 30 minus 30 minus 8, that is equal to 32 kilonewton. minus 30 minus 18, that is 12 kilonewton. Now the bending moment, what is the maximum bending moment? It is supposed to be the place where x is equal to 0. As you know, the shear force is 0 at the point 10 minus 6 is equal to 0, or x is equal to 2.5. Then we know that at the maximum bending moment, position of maximum bending moment, shear force will be 0. So if you put x is equal to 2.5 meter, then maximum bending will be equal to 10 into 2.5 minus 2 into 2.5 whole square, or 12.5 kilonewton per meter. The portion CD mx, it is here to here. That is from, if we take the x from here up to this portion, so the section here from the left of the x section, there is a distributed force over the surface and a one reaction acting at the end point A. So what will happen? X multiplied by RA, which is equal to 10. X, which is equal to 10 minus 10 into minus 12, 4 into 3 multiplied by x minus 1.5 linear, and CD. There is couple is acting at the point D, so it is not coming in the picture. So 10x minus 12x minus 1.5, or MC will be 12 kilonewton. If we put the value of x is equal to 3, MD will be 5. So at this is 8 kilonewton per meter. The portion DE mx, we can use this first portion of this equation, plus we can add the couple which is clockwise in nature, so it's positive. So we add it 10 linear. So D is equal to 2.x is equal to 5, 80 kilonewton per meter. When if we put x is equal to 5 here, and D will be x is equal to 8, 12 kilonewton per meter. The portion EB 10x minus 8, 12 into x minus 1.5 plus 10 minus x 4 into x minus 8, which is happening if you take the section here at this position. So it will be added by value x from the left hand. So we multiplied you can multiply it by uh, 10 into x, take multiplied by x, that's the moment, and which is clockwise, so it is positive, minus 12 into x minus 15, means 12, 4 into 3, acting at this middle point. That midpoint is away by 1.5 from the left hand, so total x minus 15, x minus 1.5 plus 10, 10 is the clockwise, is the anti-clockwise direction, so it is positive, which technically we can put it in here. So D at x is equal to 5 is equal to 18 kilonewton per meter, and MC x is equal to 8 is equal to 12 kilonewton per meter. And portion, last portion EB, mx is all remains same, plus only one thing is 4 multiplied by x minus 8. And it is acting anti-clockwise direction, so it is negative. So ME x is equal to 8 at the point 12. X is equal to 12 kilonewton per meter and MC 0. The bending moment diagram has shown above here. Here it's up to this the parabolic nature 1.2. Now let us go for 4.21 problem. A simply supported beam of 8 meter span carries a uniform distributed load of 2 kilonewton. That is uniform distributed load 2 kilonewton, and per meter on the left hand of the beam. It also has a point load of 25 kilonewton. It also has a point of 20 6 meter away from the left hand. Actually, it will be 5 kilonewton. Let us see. The beam will subject to a counterclockwise couple at 20 kilonewton at the left end and clockwise couple at 30 kilonewton at the right end. So draw the shear force of vertical diagram to get the principal value. So maximum value you have to indicate. You have to draw the shear force of vertical diagram with it. So here we have the distance between A and B. The value of B is equal to 4 into is equal to 4 is equal to 2 kilonewton per minute. And again, there is a counterclockwise couple at the end A and another counterclockwise couple at the end B. So equal to 30 kilonewton. So the shear force of multiplier you have to drop accordingly. So here what you have to do, first of all, we have to take the reaction at A and at B. If you take the reaction, take the moment from about the B, what will happen? The distance of the point A is 8 meter away from B. So R into 8, it is positive as it is making clockwise direction, and 20 kilonewton, which is equal to 20 kilonewton, which is negative, it is making it 84 RPM. And 24 RPM. 20 plus another is 4 into 4, 2 into 4 into the 6 means the distance 2 into 4 into the 6 plus 25 into A minus 30. 6 means we take the midpoint about the line of action. So distance will be from the midpoint to and the C, say 2 plus 2 plus 2, that is 6. 6 here. 25 or 5, it is actually 25 kilonewton. So 25 multiplied by 2 is equal to 25 multiplied by 2 minus 30 multiplied by 2 is that which is equal to minus 30. It is acting in different form, acting equal opposite direction. So RA will become 10 kilonewton, RB 10 into 4 into 2 into 4 into 2 multiplied by 25 minus A. So the vertical forces are here, the distributed forces of 4 meter length of 2 kilonewton per meter density, that is 4 into 2 plus vertical forces 25 kilonewton and minus the reaction RA, which is equal to 11 kilonewton. So 4 into 2 plus 8 plus 25 minus 4 is 28 kilonewton. Now the portion AC, what will happen? Fx minus 2x, where Fx is equal to Fa is equal to 12 here, where Fa is 12 and at a distance x, if we take the section here, the intensity of the distributed force will be 2 into x, which is acting downwards, and if the reaction of Fx is acting upwards. So Fa minus 2 into x is equal to 0, minus 0 is equal to 0. Here RA multiplied by 8 and 20 is equal to 20, that is the reaction, equal to RA multiplied by 8, which is acting upwards or clockwise direction, which is equal to 20 kilonewton, which is the couple acting at A, and it's equal to 20 kilonewton. Plus 4 into 2 into 6. 4 is 2 kilonewton per meter, length is 4 meter, and 6 is it is the 6 is the distance of the midpoint from the point P. That 4 plus 4.5 meter of 4 plus 4 divided by the half of the distance between A, C, that is A and C, that is equal to C. Thus, it becomes 4 plus 4 plus 4, that is equal to 6. Plus 25 into 5, 25 into 2, that is 2 meter. It is acting 2 meters away from point B and becomes 25 into 2. And thus RA becomes 11 kilonewton, and by resolving all the vertical forces acting on the beam, we have 11 kilonewton minus which is acting downwards, and 4 kilonewton into 2, we have 2 effort, and 25 kilometer is acting downwards. So 4 into 2 plus 25 minus 11, 25 kilonewton. Next, let us go for the shear force diagram. The portion AC. If you take the section here, like say, if you take the section somewhere here, in between this point, there is only one force is active, that is the force RA, which is equal to 11 kilonewton, and the couple if 6 no, we are taking the shear force, the couple will not come into action for it. That is reaction A, R is equal to 30, and the remaining of the ground, remaining portion of the body which has distributed force will be inverted by again and it is from A to C. The RP is equal to 4 into 2 plus 25 minus 11. That is 22 kilonewton. We have already calculated. So here that is RA is equal to 11 kilonewton and FC is equal to minus 4 into 3 kilonewton. So that's portion CD is 11 into 1. Here from here to here from the left to the portion X here, one force is acting 2 kilonewton per X and another force is 4 kilonewton 24 kilonewton per day. Thus, if you put the value of X here at X is equal to 0, RA is equal to 0, shear force is here, RA and shear force is 3 meter. Thus, CD between C to D, Fx is 8 minus F minus 8, 0 to 32 kilonewton. Then within the structure CD, here also couple is not will not be effective that because it is not creating a vertical moment. So 11 minus 8 is equal to 3 kilonewton, and that from dB 3 minus 25 minus 24 kilonewton. Next, the bending moment. Mx, the distance of the reaction RA is the X is the intensity of the reaction RA multiplied with the distance from the X section. It will become 11 to X and it turn down the value in order to maintain equilibrium with the loading. 11 minus X minus 20 minus portion AC level minus 20 is the distance of it is the reaction RA. Bending moment, I don't know. Is RA into 2 into X square by 2. What is here there is a 20 kilonewton enacting with clockwise direction, anti-clockwise direction, this is negative, and the moment of the distributive forces will be divided 2 into X multiplied by X by 2. Thus, 11 X 20 kilonewton, 11 X equal to 20 kilonewton minus 2 X square by 2 is equal to 11 X minus 20 minus X square. Now, MA minus 20 and MC 8 kilonewton. If we put the value of X is equal to 10. Then between the portion CD, the initial portion 11x minus 20 remains as it is and minus 8 into x minus 2, that is the distance of the force F from 8. It is the distance of the distributed force, that is 8 multiplied by x minus 2. So at MC 8 kilonewton M and MD the 14 kilonewton N. And thus the portion dB mx is for 5 remains set only by 25 kilonewton. Its distance is from the distance x to the x minus 6, that is 25 to x minus 6. Thus d is equal to x minus 6 is equal to minus 16 kilonewton M and MC is equal to x minus 8 is equal to 30 kilonewton M. So this is 0 at x is equal to 20. 6 minus 8 minus 20 is equal to 0 or x is equal to 6.64 meter or 8 minus 6.6 or 1.36 from B. So bending moment diagram is given here. It is become 0 here, then it will become negative. Here from negative it is become 0 here, then it become positive. Next problem is